First up, we have Glen Gerhard. He's VP of Product Management at Sansay. He has a background in both carrier and vendor corporations and brings complex issues into focus and context. Before joining Sansay, he worked for Network Equipment Technologies as a systems engineer and later product manager. And he's also worked for New Era Communications as a product manager and later VP of Business Development. And we also have Andy Huckridge, Director of Service Provider Solutions at Gigamon, presenting. And Andy, as Director of Service Provider Solutions, spearheads the strategy for Gigamon's entire spectrum of global service provider solutions. He previously worked at VSS Monitoring, and he's also worked for Spirent and for 8x8. So I'll welcome now Glenn.
Just stay up here. Oh boy. Let's see. How do I bring up from the desktop? My files on the desktop. Ah, okay, super. So now you got to go back. Thank you. So yeah, aside from the similarity in name with Sansay, we also have, I think, a similar perspective on software versus hardware. We got started in 2002 with a software-only session border controller, and that was when things were probably not as powerful as systems as you can have today, of course. And a lot of people were kind of surprised that we thought we could run a large capacity VoIP calls through a standard COTS hardware. However, has proved to be
I don't think that's yours.
has proven to be very successful, and we now have over 300 customers. We've been profitable for the last 6 years. Similar to Bill's company, we didn't have to go out for any VC funding, so we're privately held and very self-directed. And I think we're super customer focused from that perspective. So looking at the virtual appliance world and how that will really build into new services for telcos as well as carriers as well as enterprises, I think there's a couple questions about where's NFV really going to take hold first. And obviously this is the Software Telco Congress, and in my opinion, I think the telcos will be lagging the enterprises in terms of deploying NFV solutions. And there's a couple of reasons for that. Is obviously the core carriers are moving that way. The Cisco presentation this morning was showing, RFP after RFP, and AT&T, Verizon, all these people, Cablevision, Comcast, they all have ongoing projects to virtualize their network, and there's no doubt that that's where they're heading. But it's a much more complex migration for them. The BSS and OSS system, which IBM was mentioning yesterday, is a very real thing for these carriers. It's a major part of their operation. It's a major part of their investment, and it's going to be somewhat complex for them to integrate these new systems and new processes into their company. It's like the joke of, how did God invent the world in 6 days? There was no installed base. So the carriers are kind of stuck here. They want to go there, but they have, 5 nines responsibility. They have all these challenges in front of them. There was a panel today also talking about, is this going to save carriers money? The real-time group that was up here, they basically all said no. It's not going to save carriers money, and at least not initially. So I think the carriers have to have a reason to, really turbocharge this to get something deployed in a short amount of time, and I don't think that necessarily is the case yet. One of the talks yesterday, I think the carriers or the speaker said that the mobile guys are trying to roll out LTE and they haven't finished, paying off the 3G rollout. So it's a matter of you have to have a kind of a network inflection or some reason for them to say, okay, I've got all my deployed stuff, but I'm going to replace it now with new NFV type systems, and I'm going to make money or save money or provide additional services this way. And I think that's a kind of an interesting problem for them, but obviously they will get there eventually. But I really think that on the enterprise side, the SMB market, it's a different paradigm where they're able to, I think, justify the transitions a lot faster. Their networks are generally segmented and a little bit easier to manage a transition, such as going from distinct hardware appliances into an NFV type solution. So if you look at a typical branch office, it's like, okay, what could be virtualized out of these type of appliances? And I think really almost all of them. If you have an end user out here, they could be getting their desktop from a Citrix file server. They could be using a Microsoft Link IPBX. They could be using an Adtran Wi-Fi, Sansay ESBC, or Adtran ESBC, Cisco firewall and Cisco router. I mean, all that stuff is now available in a virtual context. So there's, I think, a lot of opportunity here to get all of these devices into a single virtual paradigm. And the key piece that's missing, these parts are pretty well understood, I think. Amazon and Terramark, they've kind of taken this to a very high level of understanding. But the orchestration is, I think, where things are still kind of to be determined and not necessarily, not all the parts of the puzzle are there yet. Primarily because these applications that are now running on your VM can be distinctly unique from different manufacturers. It would be great if, not sure how to go back, but if all of those systems on the previous page were from the same vendor, gee, that's great. I'll buy it all from Cisco or I'll buy it all from Microsoft and I'm done. But in reality, you generally will find a variety of manufacturers within a particular enterprise branch office or even a major location. So the orchestration now becomes, okay, well, dealing with Cisco here, Juniper here, Microsoft here, Sansay here. How am I going to get this, really to behave in a way that's understandable and maintainable? So if you look at kind of a potential architecture for an enterprise, anyway, the virtual machines may be out here. Okay, there was a couple different deployment options that people were outlining to say, okay, is your virtual machine here running all of these applications here, or you can have the virtual machine actually in the cloud. It could be at your corporate headquarters, and you have these different deployment scenarios about where the actual instances are running for those appliances. Depending on, say, things like your resiliency, how resilient do you have to be? If this link can always go down, you absolutely have to have an ability to say, okay, well, what happens if this goes down? Gee, do all my phones go down? Well, that's kind of a problem for some companies, especially if you're a call center. If, on the other hand, you're a manufacturing plant, maybe that's not not a really big problem. You can continue to operate. Or is your system control, is your actual manufacturing control systems now virtualized and running somewhere? So obviously, if you tend to bring the branch or the virtual appliance hypervisor out onto the branch itself, you get a more redundancy out of that. I don't think the resiliency should be pretty obvious that that there is going to be value add in that. But the benefits are really kind of listed over here. your whole network becomes much more flexible in terms of the data formatting or the data flow within your network. Okay, I can literally have two systems talking at layer 2 from this site to this site if I have my virtual appliances set up correctly. So that leads to more flexible and faster deployments. You generally get combined licensing across your network if you go with a centralized VM. And you also get coordinated workflows so that your management tasks actually become much lower once you get this deployed. You still have the migration, you still have the installed base problem, but once you've achieved this, it's essentially controlling your entire network from one dashboard on one site, all of your routing, all of your call control, a lot of your application can be handled from that one dashboard. So you have a number of ecosystem players, right? There's, I think both from the vendor side, like Sansay was talking about, Bill was talking about, it makes a lot of sense from a vendor. We don't really like the hardware world necessarily. It's a slow-moving and expensive approach compared to what we can do with the software solutions. So the ecosystems are going to be, these people are really focused on this, as are we. One of the interesting ones, I think, that at the hardware level was the Open Compute platform. I don't know if you've heard about that. That's like a top-of-the-rack system. It's a 48-port switch and hypervisor-capable system that's being released, and it was engineered by Facebook. So you can throw Facebook into your hardware providers now as an option. So you have, obviously, that. You have relatively limited number of VMs you can choose from. And the VMs generally are somewhat independent of the OS. Generally, any of the VMs can run any of the OSs, and any of the OSs can run on any of the VMs. Your applications is where you just have a huge growing number of applications now that can run on it. It doesn't matter whether it's a PBX, an MCU, whether it's real time, whether it's a file server. Those applications are there and are going to become really, really easy to deploy within the hypervisor world. The orchestration layer, sure, this is where I think there's a lot of motion and a lot of things that are going to be in play for quite a while. And that's probably, I would say, maybe the lagging or the layer that's going to hamstring us the most in terms of actually getting wholesale migration onto the VM NFV formats. And not necessarily doesn't, VM is often confused, I think, with open source, but it certainly lends a lot of power to the open source world that, okay, if I'm running on a VM and I'm running on a standard OS, that's a perfect platform for an open source solution. So what do you do if you're a carrier, or if you're also a telco could be providing managed services to these enterprises, right? So if I'm providing managed services to an enterprise, that is a telco offering and does lead, I think, telcos into that space kind of gracefully. Say, okay, well, I'm going to manage these NFV solutions for my enterprise customers. That's a great lead-in to say, okay, now I'm going to take my core backbone of my major LEC or mobile carriers and try to migrate that to an NFV solution. So there'll be some good, learning experience there. But the key thing is, what group is going to actually lead and be kind of the linchpin of my ecosystem? And so I think that depends on your basic business. If you're a call center and basically if that's your enterprise and that's your business, well, your PBX application is probably going to be the one that drives your ecosystem. You're going to take that application and find out who they work with, what their orchestration layer is, who their partners are, et cetera. Manufacturing, that would be your control system, would be a likely scenario, or your file system or your ERP application. And you just need to kind of say, okay, well, what's the core focus of my business? What's the ecosystem and NFV solution that they can work with? So if it's a LEC or a next-gen telco, you're going to have very divergent things, solutions. And also if you're cable or these guys are, I think, are going to be driven almost entirely initially by the BSS OSS. That's going to be the most complex part for them to manage to transition into this world. So they'll be very focused on that as their solution vendor. Part of that also comes out with troubleshooting and monitoring your network. How do you get, in this lovely virtualized world where I think Bill was talking about, hey, how many CPU cycles and DRAM does it add when I add this feature? Okay, that's a really powerful statement. Only kind of problem is, gee, this feature, I just upgraded the code on this system, on my application over here. Suddenly it's causing problems over here because this guy's now being starved for CPU cycles. So there's, the hypervisors and the physical hardware layer can only do so much. If your application suddenly, you upgrade this application and it's having problems and it's sucking up all your CPU, that can be a serious problem for your network. How do you troubleshoot that? How do you manage and monitor your network so that when those type of problems exist, that you're able to respond effectively to say, oh, that problem is that upgrade that I did, I need to shut that down or roll back that particular application. That you need to be able to discern very quickly. So with that, I think that's a good lead in to maybe what Andy's going to be talking about here. I still haven't figured out this presentation thing here, but let me see. Hey, Eric, could you give us a hand here again to switch the presentation?
See if it was virtual without this solve.
I went first on this conversation so that, because I've known Andy since he was a young tyke at 8x8, so I figured if he went first, I wouldn't get a chance to talk.
How do I follow that, huh? See, I cheated, so you can tell it's my presentation because mine's on a Gigamon background. So Eric said to me earlier on, he has to guess as to which presentation is the right one. So mine's easy. Okay, hi everyone. Thanks for joining us today. So what I'm going to talk about is actually related to what Bill was talking about a little bit earlier on, and then follow up with what Glen's talking about as well. So I'm going to paint a slightly different picture. I'm going to paint a picture of, so now we've moved to a virtualized set of services, a virtualized set of functions on the network. How do we monetize those? And how do we help service providers to assure that those revenue streams are actually going to be developing revenue all of the time? So Gigamon is in the field of service assurance, network visibility. Bill did mention visibility, and we're in network visibility. So what we're going to be talking about in more detail is how to optimize the tools layer, which may or may not be virtualized, but how to optimize that, how to save carriers costs in terms of OpEx and CapEx at the tools layer, as well then as deploying services and a new type of tool called customer experience management to monetize the service of the data that's already on service providers' networks. So this is a slide that our lawyers like us to present, but I don't think I've ever actually read it. But anyway, moving right along. Okay, so what's the status of the industry? Well, there's lots and lots of traffic, and it's growing. So you can get this from Cisco, you can get this from Ericsson. The most frightening thing for all of us is the following. We can't produce hardware that'll sit in a single box that will process all of that lot in the future. So we all have to move to a more software-based way of doing things. We all have to move to a more cloud-based way of doing things because we just physically can't process at the tools layer for monitoring the network the types of traffic that's going on. So this should frighten all of us, frankly, because we can't monitor, we can't analyze, we can't understand all the different types of data that are out there, to be able to get a grasp of what's going on visibility-wise onto the network. Now, when you multiply that by the complexity of the different types of traffic on the network, you soon find yourself not really having an idea of where your traffic is coming from, where your traffic's going, the different types of traffic, even if those traffic types, if you're being paid to carry those traffic types, or if you're, if you're carrying those traffic types on your own back pocket in terms of over-the-top traffic. So this speech is going to be all about how to monetize those services and how to virtualize the capabilities to monetize those services. So hopefully we'll have some service providers in the audience. Do we have any service providers in the audience? There's 1, 2, 3, okay. And I know service providers like to be mysterious, so there's probably more than 3 here, but we'll leave it at that. Okay. So this is the crux of the problem again. So we've got this perfect tidal wave. We've got the ARPU per bit, and Bill actually, I think, covered ARPU already. The average revenue per user is going down. And what Bill said was that we can't install services fast enough to overcome the ARPU reduction problem. And I would agree with that. So the money that the carriers are generating is going down. The amount of money they have to spend to put new pipes in to carry all of this data is rising. So already you've got two things that are juxtaposition to each other, opposites to each other. Now in the world that I live in, it's all about tools. And tools are based on hardware, and tools cost money. And if we look at the cost of what a 1 gig tool cost way back when, it was about $10,000. And now we have carriers that are deploying 10 gig tools, and they cost, for argument's sake, $100,000. So if you're good at math, and I'm not very good at math, you can see that there really wasn't very much of an increase of efficiency of moving from 1 gig to 10 gig tools. You basically were the same as buying 10 1 gig tools. So what happens when we go up to 40 gig tools and even up to 100 gig tools? Are we going to get any efficiencies of scale, or are these tools really going to cost that much? Because if they do cost that much, then that's the business model of carriers that we know it today, basically gone out the window. Nobody as a carrier can afford to buy tools at that level, at that cost. So if we move to network function virtualization, and if we virtualize various points on the network, we can offer not only the tools, but we can offer optimization capabilities that will allow the tools to process more effective bandwidth. And that's sort of what I'm going to get to today, and also show how operators can use NFV and functions like NFV to get more revenue in, more revenue streams. Okay, so how do we incrementally advance the whole monetization thing here? So there's a new series of tools that have come out called Customer Experience Management Tools, CEM. And what these do is essentially they add what we would call the Gigamon, the Google model to what carriers can do today. So you can look into pipes, you can analyze the data on those pipes, you can work out what subscribers are doing, why they're doing it, you can discern all of these patterns. And then what you can do is, if you wanted to as an operator, given that you understand, or you can analyze this information, and that's where Gigamon comes in, we help you to be able to analyze this information, you can then adjust pricing plans to allow for certain types of services to cost this much, or certain types of services to cost that much. And you can have certain data types to, again, cost this much or cost that much. You can do it location-based and things like that. So we help to allow the service provider to get the most amount of value out of their network in conjunction with these new types of tools, customer experience management tools. But not only that, we're helping the service provider to reduce the costs of the tools effectively, because we are optimizing the data that goes up to the tools. Now, what do I mean by optimization? So let's just say that you've got a network that's not running very efficiently, and there's a lot of fragmentation of packets on that network. So it really doesn't make a lot of sense to have the tools to do the defragmentation when we can do that at the layer below in terms of the visibility layer, and then pass very clean data out to all of these tools and do the defragmentation once, rather than having each particular tool to do the defragmentation over and over again. So that's one example. If a tool only needs to see video, there's no point sending voice over IP to it. If the tool only needs to see voice over IP, there's no point sending video to it. So all of a sudden, you get to see, the tools get to see the data that they're expecting to see, and none of the data that they're not expecting to see. They get to see clean data that's defragmented, and all of these sorts of things. So we help to make the tools layer that much more efficient. Anyway, so that's enough about that for the time being. But essentially, there's a path here for service providers to increase the ARPU and to then get more revenue streams in. So there's a number of things that these tool vendors don't have today that we provide. One of which is GTP correlation. So if we've got any net heads in here versus bell heads, this is always an interesting one. So bell heads know a lot about the whole concept of a user plane and a data plane, and the net heads have always said, well, they're all just packets running on a network. So they're both right, but of course, in our new way of doing things here, we've got a user plane and a data plane running on the same packetized network. And if a tool can't get to see both the user plane and the data plane, the control plane and the user plane data correlated together, then by the time you send that information to the tool, all relevancy of the data is lost because you can't correlate which pipe the traffic is flowing over, which user. It actually goes back to what Bill was saying. It all comes down to the flows. If you can't capture the entire flow for a specific user, for a specific subscriber, then you can throw away that data because it's not relevant. Now, the other thing that we can help you with as well is in the world of big data, right, as I covered right at the start of this speech, there's more and more and more data. So that's just an inalienable fact. You can't get away from that. So how do you solve this more and more data problem if you don't have the cash in your back pocket because the ARPU is going down to be able to analyze all of this data, to do the Google model, to derive revenue, to get statistics out of the data that you're carrying as a service provider, to be able to get the revenue streams out of it. So we've come up with a way to do statistical flow-based sampling. Bill did a great presentation. I'm just going to reuse a lot of the words that you used in your presentation, actually. So we've come up with a way of doing statistical flow-based sampling that will allow the carrier to look at, for example, 5 or 10% of the traffic, or maybe 50% of the traffic. It just depends on what they want to look at. Of a certain traffic type, and maybe 10, 15, 20% of a different traffic type. So if you've got a pretty rock-solid voice over IP implementation, you don't need to look at 100% of the traffic. You can look at maybe 10% of the traffic. If you've got a troubling video implementation, then maybe you do want to look more at the video traffic, so on and so forth. So this is a way that you can harness big data. You can look at all of that big data, but in a much more controlled, flow-based, sampled way of doing things. So what I'm showing you are some of the techniques that live in software. They don't live in hardware. And these are the things that will eventually move out into the cloud, in a network functions virtualized sort of way, that the tool vendors will then be able to take advantage of to be able to lower the costs overall to get the ARPU up for the carriers. So here's the actual example of what I'm talking about here. If you've got a whole bunch of tools, and these tools don't have the capability because they're sitting in a virtualized layer of connecting directly into the network, then we can help with that. We can grab a hold of that data, we can correlate it. There's no tools out there today that can connect to multi-40 gig or even to 100 gig pipe, so we can help with that and correlate that data for you on a mobile network. If you don't have the ability in your tools, and as a service provider, you don't have the cash to buy more tools, then we can cut that data down, we can reduce the data down and just provide you with a flow-based sampled system so that you can take a look at only certain traffic types and at certain levels. So these are some of the ways where at least you can extend your business runway in the software world as a service provider rather than rushing out and buying more hardware from a tools perspective. Okay, so I'm going to skip over that one. Okay, so what does this all give us here? So what's the upshot of all of this? So the upshot of all of this is that carriers don't have the money to spend on tools as we know them today. They don't have the money to spend on the infrastructure. Everything's moving to software. That I understand. That we all agree upon. The specific thing, though, to bear in mind is you can't process all of this data to get the revenue out of it if you're a service provider unless you move the processing of that data into an elastic compute structure which sits into the cloud. Now that's, of course, where NFV comes into play, network functions virtualization. So Gigamon as a company can help you to get that data into the cloud, where you can do an Amazon type of processing capability on it. And I don't know if anybody saw the Amazon Kinetic release recently, but where you can analyze huge amounts of big data sitting in the cloud. That, as a carrier, will then help you to get a new revenue stream in. So that's where we can help you here. So we can reduce down big data, we can increase the tool throughput, and then finally, you get a convergence, and that will help you because you can get revenue from the ARPU stream by, as a service provider, by selling that information to marketing houses and things like this. So that helps you with your business runway. Oops. Now that is interesting. We've got one slide there and a completely different slide here. I've never seen that before. Anyway, so just one final slide here really quickly. So this is where we're going on the monitoring side of things. So we're moving to an all software monitoring model by which we don't know the applications that you as third-party equipment providers or you as service providers want. So we are moving to, in conjunction with SDN, we're moving to have the ability to have third-party applications to control us. So you can tell us what data to grab off the network and send it to whichever tools. We can have an API to go back and forth so we can communicate with the tool and say, we're seeing this level of failure in the network, please send more of this type of data, or we don't see any failures of this type of network in the data, of this type of data in the network, don't send us as much of this type of data. So this is the whole brave new world of software, of monitoring for the service provider, which you can effectively think of as software-defined monitoring. Okay, so that's pretty much it. And then, Glenn, I guess we'll do a back and forth now.
Any questions that anybody in the audience has for Andy or myself?
I have a mic, so I guess I'll go ahead and start it out. I was going to pass it to an audience.
Any questions other than Paula Bunier? Sorry.
There was one up here, actually.
Oh, was there?
Yeah.
Great, go ahead.
Sure. So the question was, what was the type of sampling rate that we can do with telcos? So I'm going to go out on a limb here, and I'm going to say that I'm thinking you're coming from an OSS BSS type of question there. So in terms of the sampling, we would sample all of the packets in real time, which would not be an OSS BSS thing, but all of the packets on a flow in real time. But the sampling is more of a statistical sampling, not a time sampling. So we can sample from nothing to 100% of the packets that we see on a link coming through, as opposed to like a time-based interval. It's not time-based, it's flow-based. Does that answer the question? Yeah. Okay.
I guess from the OSS, how deep do you get into your package? Do you see call flows and you just map out flows? Or if someone wants to go deeper, you see, okay, yeah, this is a SIP pack, this is a VoIP call.
Understood. So the question was, from an OSS perspective, how deep can we get into the packets, into the flows? And I think both Glenn and I will have an answer for you on this one because he's coming from the session border controller side of things. From my perspective, we can correlate all of the packets from a specific session or a specific user, IP address, IMSI, TEID, what have you, or even for SIP, for example, and then provide all of those packets out for a specific communication flow into a monitoring tool or an analytics tool of whatever you're choosing would be. Now, from your side of things.
Right, from our perspective as a session controller, we would be looking at things such as registration, number of session attempts within the web RTC space. It would be more a matter of the JavaScripts that were downloaded to a particular user. And that would go into essentially a file that would be read by your monitoring system or your billing system. And then we could also do essentially real-time tracing on particular IP hosts or users.
Map it out nicely.
In Wireshark. That would be a Wireshark. Yeah. Wireshark would do the diagram for you.
Another question?
Yeah. How do you deal with encrypted flows or encrypted payloads?
That's a great question. So from the monitoring perspective, I'll jump ahead and I'll say that you're probably looking at SSH or SSL, whatever, right? If the entire packet is encrypted, then we would have to tap into the network at a decryption point, where the SSL is being decrypted. If it's just the payload, then we would forward on the payload because we can read the header. So that really depends. It's sort of interesting. That takes us into the direction of some of the most recent market developments in the US and around the world. We now see certain markets, some European markets, that are very hot and heavy against or for using encryption and not for passing through any sort of US type of node. And we see markets in other parts of Asia that just don't care less about that and everything is open. So it depends on where you are in the world as well as to how deep we could go to solve that problem.
Yeah, and that's kind of an interesting perspective also within the VoIP space, in that a lot of endpoints now, especially in the enterprises, are moving to TLS and SRTP. So the standard monitoring ports on your switch can't really do much with that traffic. It's all hidden. So it really has to be somewhere along the signaling path that has, in essence, the TLS certifications and keys that can do that decryption and branching off of that flow into the monitoring ports. The same as with WebRTC. The media flows over SRTP. The encryption keys are passed with DTLS. So if you want to decrypt that, you really have to be one of the signaling elements or one of the elements within the actual media path, media layer.
So Paula, did you have a question, by the way?
But did we have another question back here? Any other audience questions?
There's got to be one more, surely. No? I think I'll have to ask Glenn a question, or Glenn can ask me a question. I'm just kidding.
Well, that's actually perfect timing. Thank you so much, and thanks to our
Thank you.
audience.